Hi everybody. So we are now getting our next lesson, and that is all about rate of change and slope. And our goal for this particular lesson is to find rates of change from tables and also to find the slope. So what is rate of change? Okay, so when we talk about rate of change, it actually shows the relationship between two changing quantities. So it involves two quantities. One is a dependent variable and an independent variable, as we have discussed that from previous lessons. So when we are solving for the rate of change, then that will be the change in the dependent variable divided by the change in the independent variable. So whatever situation you are given, and typically you will be presented with the data of values, you will always have to identify which one is your dependent values and your independent values. And all you need to do is find the difference. So you have to subtract two dependent values and then divide it by two independent values. So let's have an example here. So as you can see, this table here shows the distance a band marches over time. So the time is expressed in minutes, and as you can see, distance is expressed in feet. So the question here is the rate of change constant? Is it the same all throughout these pairs of values? And what does the rate of change represent? Okay, so if you would remember, when we talk about rate of change, okay, rate of change is the change in the y values. So change independent values all over change in independent. Okay, independent. Now remember, when you are given like an x and y values in your how do you call this, in your table, your dependent values are your y values, and your independent, these are your x values here. So when you're looking at rate of change for a given table of values, what you can do is you select two pairs of values. So let's select 1 and 2 as our time. Okay, so you can see that the rate of change, I'll just use ROC. Okay, the rate of change is going to be the difference between the y values, which is the distance. Okay, so it's going to be 520 minus 260, okay, divide it by the difference of your x values, and so in this case it's 2 minus 1. Okay, so if you take a look, 520 minus 260, that's going to be 260 again, and then it's going to be over 1. All right, now when you select a second pair of points, for us to be able to know if the change of rate of change is consistent, it has to be the same value. It has to come up as 260 over 1 every single time. Okay, so let's try to have 3 and 2. Okay, so this is going to be, let's see, is the rate of change for that pair going to be 260 over 1. So we have 780 minus 520, and this time our x values will be 3 minus 2, and you will see it's going to be 260 over 1. And you can check finally with our third pair. Okay, so 1040 minus 780, divide it by 4 minus 3, you will also get a 260 over 1. So the question is, what does that rate of change represent? 260, if you would remember, is the distance. Okay, so what does that mean? The band gets to march 260 feet for every 1 minute. Okay, because it is consistent, it's always 260 feet over 1 minute. So that's the representation of this, I would say, the speed, how fast or what distance is getting covered for every minute that the band marches. Okay, so that is what rate of change represents. Okay, Now, we mentioned that we are to cover slope, and slope is also, this is the best example of a rate of change. It shows us the ratio between the vertical change and the horizontal change between 2 points of the line. So following the formula of the rate of change in dependent variable, you will see that the slopes formula, oops, sorry, my bad. The slopes formula will be the vertical change. So it's going to be the values of y, okay? So you have y2 minus y1, okay? That's the difference. Divide it by the change in the independent variable. And so that's our x in our ordered pair. So x2 minus x1. Okay, and I'm pretty sure that you have heard this in middle school. When you talk about slope, it's always as rise over run. So the reason why it's called rise over run is because the rise technically is the change, the vertical change, the change in the y values. And so you have there the y2 minus y1. Run is the horizontal movement. And so you can see that's the horizontal change, all right? So let's take a look here. So if you are given a graph of a line and you are being asked what is the slope of each line, all you need to do is find two distinct points, okay? So always find two distinct points. Now, if you would remember, slope, rise over run, okay? That's what you always remember. Okay, so you select one point of origin, okay? One point that you will use as your reference first. So from this point, going to this other point, how much do you go up or down, since we are talking about the rise or the vertical change? So from here, you need to go 1, and then 2. 2 going up. Okay, so the rise is 2 up over the run. You have to go left or right, that's the run, and then you count. So it's going to be 1, 2, 3, 4, 5. So it's going to be 5 to the right. Okay, now when you are going up, that's positive. If you're going down, that's the negative. All right, so here we have a positive 2. And then 5 going to the right. If you look at your number line, right is positive, left is negative, all right? And so it's going to be 2 over 5. That is the slope, okay? So why don't you try this second example here? Find the slope of this line. Go ahead. So for this example, our slope will be negative 1 over 3. Why is that? Again, slope is rise over run, okay? So if you, let's say, use this point over here as your reference, do you go up or do you go down to go to the next point? We go down, and we go down by 2. And then going to this next point, we have to move to the right. And you can tell 1, 2, 3, 4, 5, 6. So it is 2 down over 6 to the right. Down is negative. Right is positive, so it's negative 2 over 6, which you can simplify as negative 1 over 3, okay?